N represents the number of data, and the sum of x and y are the sums of x and y values, respectively, which are very simple to calculate. The other remaining terms in the formulas are the summation of x and y, and the summation of x squared, and the summation of y squared. The summation of x, y involves calculating the product of each x and y values and then summing them up. The second term, the summation of x squared, involves squaring each x value and then adding them up. The third term, the summation of y squared, similarly involves squaring each value of y and then summing them up. From the second property mentioned earlier, the correlation coefficient is between -1 and +1. If you ever get an answer outside this range, you have made an error in your calculation. So let's go to example 10.1. A group of graduating agricultural engineering students designed, constructed, and tested a manually operated crop grading machine as their thesis, using potato as a sample crop in the testing. The following data on capacity, efficiency, and the machines were gathered for 10 trials and are presented below. So these are the data that are gathered for the testing. So the trials are from 1 to 10, and the capacity is the x, the efficiency is the y, and xy, x squared, and y squared. So to get xy, you have to multiply the first x value, which is 3.52, times 83.33 is equals to 293.32. The second value is 4.15 times 76.67 equals 318.18. The third is 3.84 times 93.33 is 358.39. The fourth is 3.93 times 80 equals 314.14. The fifth is 4.25 times 70 equals 297.50. The sixth is 316 times 90 equals 284.40. And seventh is 3.17 times 86.67 equals 274.74. The eighth is 4.76 times 73.33 is 349.05. Ninth is 3.12 times 83.33 is equal to 259.99. And the last is 3.78 times 80 is equals to 302.40.